Hey guys, this is Coach Lowe, and this is Geometry, Chapter 7, Section 2. We are going to talk about similar polygons. So 7.2, similar polygons. Remember to put this in the front of your notebook also. Actually, you just need to put where Chapter 7 started. If you're making a list of the sections, though, you can do that too. But just as long as you have Chapter 7 where that began in your notebook, then we should be able to follow from there. All right, so we talked about ratios and proportions in 7.1. And now in 7.2, we're going to put those to use. All right, so first of all, let's talk about what this means by similar polygons. Similar polygons have the same shape, but they're different sizes. So have the same shape, not necessarily the same size. And if two, by the way, if they are the same size, same shape, same size, sides are congruent, angles are congruent, then they're congruent polygons, right? They're the same, they would be exactly the same. All right, so two polygons are similar. If you want to abbreviate, you can, as long as you know what it means. If and only if, by the way, when we say similar, that means similar. So two polygons are similar if and only if. So before you guys say I didn't write if correctly, that means if and only if, which means it works both ways. So we can take the hypothesis and conclusion and flip those around. If and only if their corresponding angles are congruent and their corresponding sides are in proportion. So their corresponding side lengths are proportional. All right. This number that we get when the side lengths are proportional it's called the scale factor. So when we look at the ratio of the lengths of the sides, of a similar polygon, that's called the scale factor. And just let me remind you real quick, the problem that I had you guys do in 7.1 in class, and I kind of let you figure out a way to work the problem out. They gave us perimeter, and then they gave us like a ratio of 3 to 2 to 7 of a triangle. So that then we found the perimeter of that and looked at the actual perimeter, and we divided those. That was the scale factor, because when we then took that number and multiplied each of those numbers in the ratio by it to find the actual side length. So that was actually a scale factor that we were using. And I think as we work problems throughout this, you'll say, oh yeah, that makes sense now. I understand what you're saying. So if you're a little bit lost right now, totally fine. I will catch you back up. All right. So first thing we're going to do, we're just going to list all the pairs of congruent angles and write a proportion that relates the corresponding sides to each of the similar polygons. So they tell us here that quadrilateral PQR, PQRS, so starting at P and going clockwise, is similar to TUWX, which is going counterclockwise, and that's totally fine. Let's mark the congruent angles. So just off of the letters, remember, we can mark the angles, kind of like we did with congruent triangles. So P is the first letter, and T is the first letter, so those two are congruent to each other. Q is the second letter, and U is the second letter, so those two are congruent to each other. R is congruent to W, and S is congruent to X. So let's make our list. Angle Q is congruent to angle U. Angle P is congruent to angle T. Angle S is congruent to angle X. And angle R is congruent to angle W. It does not matter what order you put these in. If you decided to start with R, that's totally fine. As long as you put R with W, you are good to go. All right, now let's match up the ratio of the sides. Again, we can do it off of these. So I'll take the first two letters here and the first two letters here. So PQ should be in proportion to TU. All right, then the next two, QR and UW. QR should be in proportion to UW. Then we'll take the next two. RS should be proportional to WX. And then the last one, PS, so from the front to the back, to TX. Now when we write these, it's kind of a cool thing. We write it like this because we know those ratios should be the same. We can write these are all equal to each other. All right, so all of those are equal to each other. Their ratio would be exactly the same. So in other words, if I had numbers for these and I divided those two, divided those two, divided those two, divided those two, I would get the exact same number because they are proportional to each other. So there would be a ratio that would be, there would be a scale factor that would be constant in all of these ratios, which is kind of a cool thing. All right, so hopefully that makes sense. If it doesn't, then please write down your question and we'll talk about it when I see you again. Go ahead right now and put a star on this page, just right underneath where you wrote these ratios. Just put a star underneath that. All right, next question. Determine whether each pair of figures is similar. If so, write the similarity statement and the scale factor. All right, so remember what we talked about. Similar polygons, or polygons are similar if and only if, first of all, corresponding angles are congruent. Corresponding angles are congruent. So as I look at this, I see we have 1, 2, 3, 4, 5 angles, 1, 2, 3, 4, 5 angles. Great. I see that I have some angles that are congruent, but there are problems right here with those. So I see that there's an issue. Angle L is not congruent to angle E. Those don't match up. Or we could say L and D. You can pick any two angles on those because this is a regular polygon, a regular pentagon, if you will, and this is not. So I have a regular pentagon, and then I have a pentagon, but it's not regular. In other words, all sides aren't the same length and all angles aren't the same measure. So this is a no, and you can pick any two that you want to. Angle L is not congruent to angle D. It's totally fine, or you could have used E or C or whatever you want to use. Same thing with K. We can go K with C, or it doesn't matter. But this is not, those two are not similar polygons. All right, let's look at this one. Now you may think, hey, Coach Lowe, you didn't give us another figure. Actually, I did. There's a small triangle, PQR, and a large triangle, PST. All right, now the question is, do I have angles that are congruent? Well, angle P is congruent to itself, and you can see that angle Q and angle S are marked as the same measure, and angle R and angle T are marked as the same measure. So corresponding angles are congruent. Now, we should be able to go ahead and write this figure down now, and then we'll look at the side lengths. Let's see if they are proportional to each other. All right, so corresponding angles. Angle P is congruent to itself. Angle Q is congruent to angle S, and angle R is congruent to angle T. Angle P is congruent to itself, reflexive property. They didn't ask us to write this. We're just supposed to write the similarity statement and the scale factor, but just kind of trying to keep these in order, and now it'll be a little bit quicker for me to write. So QRP, triangle QRP is similar to triangle STP. All right, so now I have those matching up. Now I do see that I have one mark for QP, and then this side is 2 marks. So it appears that this is a 1-to-2 ratio. In other words, the bigger triangle is 2 times the size of the smaller triangle. At least this side is. As we look down this side where PT is, same thing, right? I have 1 mark for the smaller one. I have 2 sections that are of equal length for the long one. Now let's look at the bottom part of this. The small triangle is 11. The large one is 22. Let's go small to large since I already like that. The ratio of these triangles is 11 to 22. In other words, I did QR divided by ST, basically because I had numbers, but I'm pretty sure we could have figured it out from here, right? This is congruent to this whole thing, and those two pieces are equal. This would be half of that whole. All right, so this actually comes out to 1/2 as well, which it should. So these two triangles are similar to each other, and the ratio of their sides is 1/2. It doesn't matter which side you look at. That means if I know the length of this side, if I tell you that it is 5, then I know this side would be 10. If I tell you that this is 6, then I know that this side would be 12. So great things that you could do with these. All right, let's keep moving through here. All right, each pair of polygons is similar, so let's find the value of x. So they've already told us they're similar. They have angles marked for us, so let's roll through this. So you can kind of target their angles. Angle A is congruent to E, angle B is congruent to angle F. I see that I'm trying to find this side, which I need to find its corresponding side over here. It's this one. And now I just need two sides that have numbers on them. So I'm going to choose AB and EF. All right, so that means AB is to EF as big quadrilateral side. So I need to stay with the same sides to small. All right, so I chose to write this one first. So AB, I have to have the larger figure on the top. I have to be consistent. Or if you want to put the larger figure over here in this one and over there, that's totally fine too. Just make sure you stick with the sides. But AB is to EF as DC is to HG. All right, now let's fill in the numbers. So AB is 12, EF is 6, DC is 13, HG is X. All right, we can solve this. I actually reduced this fraction before I solved because I thought it would make it kind of nice. And then, oops, that's an X, sorry. And then we cross multiply. So 2X equals 13, or X is 6.5. All right, so 6.5 for this one is the answer to that little piece HG, that little side. All right, you can pause the video and try the next three, and then I'll check back with you. All right, so now that you're back, hopefully you've paused the video. You just didn't wait for me to start talking again. I know none of you would do that. If you did that, pause the video. Come on now. All right, so we see that even though they've turned this triangle around, they can't fool us. Base angles are equal, which we know this makes this an isosceles triangle. So I'm going to use the base. So TU is to XY as, and then I'm going to pick the side ST is to WX. So 9 over 3 equals, and then x plus 5 over 4. Again, I'm going to go ahead and reduce this guy right here. So 3 over 1 equals x plus 5 over 4. Cross multiply and solve. So 12 equals x plus 5. So I don't have to do distributive property because I'm multiplying by 1, which is a beautiful thing. Simplify before you start when you can. So x equals 7, which means this side is 12 and this side is 12. Now they only asked me to find the value of x, but if we have to go another step, we totally should be able to do that. Should not be a problem. All right, let's move on to the next one that you've already done. PQ and 10/3 or UV go together. So 5 is to 10/3. Ooh, I know you guys don't like that, but we'll fix it. Don't worry. No worries, no worries. Is to, or is equal to, or is the same as 9 is to x plus 1. All right, this looks nasty, but it'll get better right now. All right, so let's cross multiply. 10 over 3 times 9 over 1. Beautiful thing. And then remember what I told you on this. If you see a plus in here, let's go ahead and throw some parentheses around it. 5 times the quantity x plus 1. All right, so we can reduce here. So I have 30 on this side equals 5x plus 5 as I do distributive property for this bad boy. Subtract 5 from both sides and divide by 5, and x is 5. Again, if I have to plug it back in, I know that this side is 6 because 5 plus 1 is 6. All right, last one on this. Now this one's kind of weird. Think about this. If I give you a value for x, which one of these two sides would be the longest? So let's say that x is 10. This side would be 12, this would be 9. So that makes this the longest side, which would correspond with this longest side. And I'm just talking about the longest side between these two. We all know the hypotenuse is the longest side of the triangle, but just compared to these two. So x plus 2 over 10 equals x minus 1 over 8. We will cross multiply again, so I'm going to go ahead and throw some parentheses around here. So 8 times x plus 2 equals 10 times x minus 1. So 8x plus 16 equals 10x minus 10. And you could probably do this without me. Subtract 8x from both sides, add 10 to both sides. So I have 26 equals 2x, or x is 13. So when x is 13, this side is 12, and this side is 15. If you have to find the side lengths again, they didn't ask me to, but we can go ahead and do that. All right, last one here, and then I promise I will let you go. If two polygons are similar, their perimeters are proportional. Now, this really takes us back to the problem that I was talking about earlier. Their perimeters are proportional. All right, so here's an example. Let's go ahead and draw two triangles. And you guys can just stay with me for this problem. You don't have to pause the video and try to work it without me unless you just want to. You actually already know how to do this, but you can work with me if you'd like. All right, so this is going to be triangle ABC. And this triangle is going to be DEF. And AB is 5, BC is 6, AC is 7, DE is 3. And triangle ABC is similar to triangle DEF. All right, so let's go ahead and put these numbers on these triangles. So AB is 5, BC is 6, AC is 7, DE is 3. If the triangles are similar, I know that their sides are proportional. I also know that their perimeters are proportional. All right, so let's find the perimeter of this one. The perimeter of triangle ABC is 5 plus 7 plus 6, which would be 18. All right, so I want the perimeter of triangle ABC over the perimeter of triangle DEF, which I'm trying to find. And I'm going to put that equal to the sides that are proportional because the ratio of the proportional sides is the same proportion as the perimeter. So I see that this side and this side go together, right? They are corresponding sides. So 5 over 3. I did ABC over DEF, so over here. So I have to take the side AB, which is in triangle ABC, over the side that's in triangle DEF. All right, so let's fill in what we know from here. We know the perimeter of triangle ABC, we found that. So 18 over, we don't know that perimeter, is equal to 5 over 3. Now we can cross multiply and get after this. So 5x equals 18 times 3, or 5x equals 54. Divide both sides by 5, and x is 10 4/5, or if you use a calculator, 10.8. So we found the perimeter. That's the perimeter of this triangle. All right. So we could also find those side links, right? We could say 5 is to 3 as 7 is to x, and 5 is to 3 as 6 is to x. So we could find the sides, and then we could also talk about the perimeter, which we already have. All right, guys, I'm through with this lesson. Hope you guys understand what's going on. If not, please write some notes down and make sure that you ask me at the beginning of class. Go ahead and circle that star that you wrote back about middle of this video, and I will talk to you soon. This is Coach Lowe, and I'm out.